guys just want to start working now and let me know if you have questions, or do you have questions now?
Number 6.
Number 6. Did we do that on Monday?
Trying to go back and
It would be super convenient if we did not.
No, I don't remember doing this one Wednesday. But I do have the answer.
3x squared plus 5x minus 4. Three x squared minus what's 5x minus 4?
Plus 5x.
Plus 5x minus 4.
4 equals y.
Okay. Any idea where to start at all? Number 6 is the first one of this section. No. How'd you do 5? Did you do 5?
Yeah.
It's very similar to 5. Yeah, it's very similar to 5. Yes, it's very similar to 5. So how did you do 5? Where'd you start?
Took the negative sign out and then completed the square.
You took something out? What?
The negative sign out.
Okay, so what would you do here? Instead of taking the negative sign out, you do something else. Something similar.
3 now?
Take the 3 out. Yep. Okay. Now.
Take 4/3 out of that.
Yeah. How exactly?
4/3.
Alright, minus here, here. Not minus 4/3, but
Minus 4.
then
Leave the square in parentheses.
complete the square in the parentheses.
3 times the quantity of x squared plus 5/3 x plus 25 over 30.
25 over what? X squared plus 5 times x plus
25 over 9. I think, no, it is what I originally said, 25 over 30, which would be 5/6.
Why is it 30? It's 5/6. 5/6. So how are you getting 25 over 30?
Take 5/3 by that by 0. Should be 5/6.
Okay, sure. 5/6. What do you do to this?
Square that. Oh, 25 over 36.
Yes, 25 over 36. So you have 25 over 36 here. What else do you need to do? Well, okay. X squared plus 5/3 x plus 25 over 36.
put you into parentheses, and then minus 4 minus 25 over 36, or would you multiply that by 3?
Because
So
when you
75
add 25 over 36, you need to subtract 25 over 36 inside the parentheses.
Mhm.
So then when you pull it out of the parentheses, you multiply by 3. So what would that be?
75 over 36. I really don't want to do that.
That. Yeah, those are both divisible by 3. It comes down to
25 over
25.
X plus 5 over 6. Squared minus 48 plus 25, 373 over 12.
48 plus 25. Yeah.
Awesome. All right.
There you go. And now you have.
That monstrosity.
That's monstrosity. Yes.
Okay.
Okay. You hate it, but you can do it. Right?
Yeah.
So, we gotta find the vertex, the intercepts, and maybe that's it. Vertex, intercepts, I guess the axis of symmetry. What else? Anything else?
I don't think so.
Okay. Find these things then, and then apply. Graph. Okay. So, vertex. This is what you got.
5, 6.
What am I at?
Yep.
5, 6, negative 73 over 12. Actually, it's negative 26 somehow.
Nice. Cool. You caught yourself without me saying anything. Awesome. No?
Mine's
Yes.
more simplified for this part. What?
What is
They just
negative 4 minus 25 over 36? Is that what you did?
Yeah.
Okay. He almost did. So. Here, there's another step. Three times x squared plus 5/3 x plus 25 over 36 minus 25 over 36 inside the parentheses. That way you can make sure that you're adding 0. Then when you pull the 25 over 36 out of the parentheses, you get 3x squared plus 5/3 x plus 25 over 36 minus 25 over 12. Make sense?
Oh, I don't know why I didn't follow through with it, but I had it here originally.
Oh,
Okay, so I know what I did. Okay.
okay. Cool. Back to pink. So I'm not kind of person. So you have your vertex. How about your intercepts? your intercepts are going to suck unless you use this version. You can do them.
Answer, because
Hmm?
shouldn't we be doing minus 75 over 12? Or not, over 12, but not. Oh, never mind. We simplified that. I'm wrong. Again.
What happened? No, tell me what your.
I forgot that we divided both 75 and 36 by 3.
Yeah. We made it 25 over 12 instead of 75 over 36. Okay. Intercepts. I'm sure your intercepts are right. Oh.
Well, I have this one, but minus up. And then negative 4. Because it's units by 2, so I shortened it down.
2 minus 12 plus 6 would be y. Y-intercept would be 1/6.
Okay. Let's see. I don't know why I wrote these. How do you get that? You plug in 0 for something, right?
Yeah, x.
X. Okay.
I actually just realized that I never did the multiplication thing. So, never, yeah.
Let's see. 3 times 5, 6 squared minus 73 over 12. That's the y-intercept. Okay. Walk me through it.
3 times 25 over 36. Minus 73 over 12. 75 over 36 minus 73 over 12. Multiply 73 over 12 by 3 on top and bottom. So,
Okay. It's going to be obnoxious no matter how we do it. So yeah, multiply 73 by 3, right?
yeah,
On top.
you can do it either way, but it's going to suck.
Yep. So what's 73 times 3?
219.
Yes. And that is something that it also looks terrible.
114. Negative 114.
Not one.
140, negative 1.
Not 114.
Negative 146.
Not
Oh, no.
146.
That's a 5.
Both of you mix up a different digit. Negative 144
Yeah.
over 36, which is really good because that is negative 4. And that's good because if you look at the original question, if you plug in 0, you get negative 4. So now we have verified pretty much that,
Could have been a lot easier.
but we've made sure that you did this whole thing correctly. This really is the same thing. Right? Because otherwise your y-intercept would be different. So, y-intercept is negative 4. How about x-intercept?
Kill me.
How do we do that?
Set the equation equal to 0.
Set the equation equal to 0. What's the equation?
0 equals 3x squared plus 5x minus 4.
I don't want to use that one.
Okay, so then 0 equals 3 quantity x plus 5, 6 squared minus 73 over 12. Could you? The 3 doesn't really look like a 3 in 73. And that all makes me up. There you go, thank you.
Maybe we should use the original one. Because this was ugly. This is going to be uglier. Right? What will we end up doing?
Putting 73 over 12 to the other side, so it'd be 73 over 12 is equal to 3, whatever, and then divide by.
Right, I'm going to skip a step. So now we have the square root of 36, so 73 over 36. Square root of 73. 73 prime.
It is.
Let's not do that. And instead, this one takes up so much room. Instead, let's go up to the top, take this one, and find the x-intercepts up here. How about that? That seems easier to me.
Yeah.
How would you do that?
Set that equal to 0.
And then,
Move -4 over to the other side.
oh, it's quadratic.
Oh. Quadratic equation?
Quadratic formula. I know that's what you meant to say.
Technicalities.
Yeah, that one. That's the. How do you use the quadratic formula? It will probably end up being horrible anyway, but
-5 plus or minus the square root of 25 minus 4 times 3 times -4. Over 6.
yes. What's -4 times 3 times -4?
48.
48. So we get -5 plus or minus square root of 48. No, 25 plus 48, which is 73. So this is still terrible. Okay, fine.
All over 6.
All over 6. So actually, this is the same as this one. That's really obnoxious. Okay, well, we already figured out 25 plus 48, so we have -5 plus or minus square root of 73 over 6. That's terrible. Can we guess what that sort of looks like? Somehow I doubt Professor Zazi thought this through when he gave you this one.
Somewhere between 8 and 9.
Somewhere between 8 and 9. Yeah, somewhere between 8 and 9.
4 over 6.
somewhere between 3 and 4. Yeah, 3 and 4 over 6. Maybe I just used too much. So somewhere between 3 and 4 over 6. So 3 point something over 6.
Somewhere close to 1/2.
Yeah. Okay. Yeah. Somewhere between 3 over 6 and 4 over 6. So somewhere between 1/2 and 2/3. And what's the other one? So -5 minus something between 8 and 9. So somewhere between -13 and -14. Or 6. Somewhere between -7/3 and
13's a
negative
prime number.
2 1/6. What's this? It's 7/3. It's 2 and something. 2 1/3.
Yeah,
2 1/3. So one of them is in here somewhere. And the other one is in here somewhere. Because the only thing left is to graph it, right? Okay, axis of symmetry. What's the axis of symmetry? You should be able to tell me, right?
Oh, -5/6.
X equals -5/6 is the axis of symmetry. Okay. Now we have all of our junk. We can graph it. Our y-intercept is -4, right? Our x-intercepts are, this is 1, not to scale, not to scale. If this is 1, our x-intercept is somewhere between here and here. And the other one is somewhere between -2 1/3, and -2 1/6. And our vertex is -5/6. Right?
-5/6, -73/12.
73/12 is 6 1/12, right? Or negative that. So that's 6. So somewhere around here. And then we draw it. Something like that. It's terrible, yeah. 73 is a really terrible number. It's a big prime, which makes it bad when you're trying to work with things. That was number 6 on 35. What? Do you have any questions?
No, I'm done.
You're done.
Mhm.
job.
No, you can't work on 6 yet,
I
right?
don't. I have my own copy of 6. I don't have that for you.
Oh, okay.
I have the answer key for 6. Answer key. I hope that I can do this stuff. You go by Xavier, right?
I go by anything that anyone wants to call me. So, sure.
You go by however people butcher the correct pronunciation of your name.
Yes. Some people call me Javier, and I'm like, well, all right.
Okay.
So which name do you prefer then?
I personally don't care. I normally just go by Xavier.
Mm.
I mean, a bunch of people in my old school told me Chav because my last name is Chavez.
All right, fair enough.
I don't know how that caught on. People that didn't even know me called me Chav. I was like, oh, okay.
It works, yeah. It means that people don't have to try to get your name correct.
Thank God.
That's the real purpose of names. So people don't need to know your real name. Any questions? Cha? Yeah, that's right.
I'm good.
I think I did have one question from the
Okay, cool.
but today's lecture might have answered it. I'm not sure. Let me just take a quick look at it.
So it's not due yet.
No, it's not due till Thursday.
So tomorrow. Okay. Yeah, logarithms are weird. Practice, practice, practice. Activity 6 is going to be, it's basically like 6 pages of logarithms.
So yeah, this is basically, well,
Nope, using logs will not help you with that.
okay, then let's go over it.
Let's go
Or
over that.
something
similar. 2x, 2 to the x equals 64. 2 is pretty simple. 64 is not simple. 64 is probably 2 to some power, right?
Mm-hmm.
What is it?
X is equal to 6.
So you know the answer and you just feel like you did it wrong.
No, I pointed to this one.
Oh shit, sorry. Aha. Okay. 2 to the something else. 2 to the x.
2 to the, I'm supposed to solve for b. So yeah, 2 to the x is equal to 116. 1 over 16, sorry.
Okay, so 1 over 16 is not so pretty. What's 16? We can write 16 as something else, right? Something made out of 2's. Right? What's 16?
So it'd be 4 to the second power.
Okay,
Or do you want me to do the other way? So it's
so
2 to the
it is 4 to the second power,
Right.
but this isn't a 4.
Right. So it's 2 to the fourth power.
And what happens when you have something on the bottom? An exponent on the bottom is the same as
Negative 2 to
not
or would
negative 2 to the 4th like that.
or parentheses or negative parentheses 2 to the fourth.
Not quite. Well, because that number, even if it's this number, is negative 16. But this is not 1 over 16, it's negative 16.
So then it'd be parentheses negative 2. So.
That's just 16. Right, because negative 2,
Oh, the exponent has to be negative, doesn't it?
the exponent
Okay.
is negative. There you go. So 1 over 2 to the 4th is the same as
2 to the negative 4.
negative.
So then
Ta-da.
the bases are the same. So x is equal to negative 4. Okay.
Yep.
That page looks good, that page looks good, that page looks good, that page looks good. I need to check that one. Your asymptotes are minus 2, so it's 3. Negative 3. That page is correct.
So it looks like you got the vertical asymptotes and the horizontal asymptote, and then just kind of went, right?
I guess.
Yes.
Do you mean like
You found the asymptotes, and then did you plug in numbers to try to figure out what's what?
yes.
What happens when you plug in the number for x?
Negative 1/3.
So why is this wrong? It looks like maybe you had this part correct before. Oh, or maybe you had this before.
Yeah, that's what was confusing me.
So
So,
you find the asymptotes. You find the asymptotes and then you just start plugging in numbers because you want to see. You found the x-intercept. That's the other one. So you want to see what happens between on each side of the x-intercept, on each side of the asymptotes. So on the left side of this asymptote, I'll plug in negative 3 over something constant, so 9 minus 4. So that's negative. So this is fine. On this side of this asymptote, I plug in positive 3, because that's in the correct spot. I get something positive, so that's fine. Here, I have to plug in numbers between 0 and the asymptotes. So between 0 and 2, okay, 1, that's a negative. So that's what is it between 0 and negative 2?
oh, okay.